Welcome to Ask and Learn.
We're sketching our function m as a function of v, so I just called it f of v. So this is our function. So first to find our domain, we have that 0 to c is our domain because it must be positive under the radical. Intercepts we have from 0 to m initial, because if we set our x to 0, we just have m initial over 1. Symmetry, none. Asymptotes, we have a vertical asymptote at v equals c, and the reason for that is if v does equal c, we have 1, so 1 minus 1 is 0, and we cannot have our function over 0. All right, so f prime of v equals, so we're doing the first derivative to see where it's increasing. This is our first derivative. C squared minus v squared cubed. All right, and we see that this is increasing over our entire domain, which is from 0 to c. So there are no local mins or maxes. And if we find f double prime to see concavity, we see cm initial times 2v squared plus c squared over v squared minus c squared, that's all squared, times radical c squared minus v squared. And we see that's also above 0 everywhere over our domain, which is 0 to c. So that means it's concave up over our domain. Right? And now we can graph our function. So it's going to be, our x-axis is going to be v, and our y-axis is going to be m, because here m is equal to f of v. All right, so we have an intercept at 0 m initial. We have an asymptote at c, and our graph will approach but not touch c.